Okay, ladies and gentlemen, in our video we are continuing our discussion of angle relationships within circles. But today specifically in this video we're going to identify two new theorems, the angles inside and outside of the circle, and use them to find some missing values of x. And then we're also going to identify three locations when we have two non-parallel lines kind of intersecting throughout a circle. So what I want to do is just pose the question, and then I really encourage you to pause the video right now to try to see if you can answer the question on your own. But think about it. You have a circle, okay? Get yourself a circle where if two lines intersect, right? If two lines just happen to intersect, they go through the circle, where are the opportunities for them to intersect in relation to the circle? Like, where can they physically intersect? Well, hopefully you started to realize that there's a couple options. Well, actually there's three options of where they can be. Intersecting lines can be on, in, or outside of the circle. And this is very fascinating because what ends up happening is in each of these different positions, they create different situations for us. They create inscribed angles, they create inside angles, they create exterior angles, they create relationships between big arcs and little arcs. And there's a lot of different information that come in just because lines intersect through circles. So let's talk first and foremost about what happens when angles are inside and intersecting, okay? So if we have two lines intersecting, where we do right here, okay? So segment AC and segment BD are our intersecting lines. What ends up happening is that these two chords, of course, will intersect inside of the circle, and that the measure of each angle, is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So let me explain this a little bit. So in this diagram, I've tried to identify them in different colors here just to kind of help things out. So the measure of angle 1, right here, the measure of angle 1 is 1/2 of the sum of its two appropriate intercepted arcs that correspond to the vertical angles. Now, I'm going to say a term here that is not a real math term, but it's always helped my students in the past. In remembering these theorems, I always tell them it's just like it was for vertical angles. We usually know that there's a connection between vertical angles as being congruent, and so what I always tell them is that this is basically the concept between the vertical arcs, right? So you're adding up the vertical arcs. Again, it's not a real geometric term or anything like that, but that concept of kind of going across an angle pair relationship like that has always kind of just helped in the past, and so kind of just think of it in a sense right there, okay? And same thing here for angle 2. Angle 2 is 1/2 of the sum of arc AD and its vertical arc BC. Let's take a look at a pretty basic example here utilizing our part A. So in this case, the measure, all right, of angle X, so X degrees, is going to be 1/2 of the sum of its two quote-unquote vertical arcs. So it would be 1/2 of the sum of 130 plus 156. So 1/2 of, let's see here, that is what, 286? 286, and then X will equal 143 degrees in the end. All right, so that's kind of the focus here of our inside angles. All right, when we're dealing with inside angles specifically. What about what happens when the lines intersect outside? They intersect outside. Well, this presents even a more of an interesting scenario, because if they're intersecting outside, there's a couple different things that these lines could be. You could have the scenario with a secant and a tangent meeting up, the scenario of two tangents intersecting outside the circle, or you could have the scenario of a secant and a secant meeting outside of the circle? Well, the good thing is that we've proven in geometry that regardless of the three scenarios that are presented here, it's the same result in the end. And what we've ended up realizing is that the measure of the outside angle created when either a tangent and a secant intersect is just half of the difference of the big arc minus the little arc, okay? So I will forever, and it's so not scholarly, but I will tell everybody forever and always that it is half of the big arc minus the little arc, all right? So half of the big minus the little arcs. I'll put little arc symbols on them as well too, okay? And I just always think that it's super, just a lot easier to remember than everything that it says on this theorem. So let's take a look here of how we can utilize this. So going back to part B now, so in part B over here, what we're looking at is we want to find that angle X. Well, the angle X here now for part B is going to be half of the difference. Well, here is my big arc AD, so half of 178 minus my little arc of 76. So X is going to end up equaling 1/2 of, what is that going to be, 102. And then X will be 51 in the end. So that's kind of an interesting example of how it can be utilized. I do want to take a look at a couple other ones on this video as well too though. So let's take a look at a little more interesting possibilities. Right here we have this angle as 102 degrees. But we want to find the measure of this arc Y right up here. Well, we just said, okay, that the measure of this angle that I'm kind of pointing to right here would be half the sum of this arc plus this arc. Or this one would be half the sum of this arc plus this arc. But I don't have this angle or this angle in this scenario. So what do you think? Where am I going with this? Well, good news is these two intersecting lines create a linear pair. And so the measure of this angle is actually going to be 78 degrees. And so we know that 78 degrees actually equals half of the sum of 95 and the measure of angle Y. So do we see where I did there? Okay, so I used my fact of my linear pair to realize that we ended up having really an angle that looked like it was missing, but it really wasn't in the end. So now it's just kind of a basic distribution, or you can multiply by 2 on both sides. It's kind of up to you. For me personally, I'm going to multiply by 2 on both sides just to go ahead and get rid of that 1/2. If I get 156 equals 95 plus Y, and then when I subtract 95 on both sides, Y of course is going to be 61 degrees in the end. All right, and what about one more? What about one more possibility using our outside angles? Well, we said that the exterior outside angle created by two tangents is the half of the difference of big minus little. So our outside angle is 30. Half of the big is A minus the little is 44, excuse me. So once again, multiplying by 2 on both sides, and then going ahead and wanting to add on over 144, we see that A will have a value of 104 degrees in the end.